Good evening to all. Yesterday, I was explaining about the interfacing of this relay. This is a small circuit what I use to demonstrate the operation of the relay. We can observe in the diagram. I have used two batteries. This battery, let's call this is the battery one. It's called this is battery one, and this is the battery two. Battery 1 is used to supply the voltage. As we know, we can apply either 5 volts or 9 volts or 12 volts depending on the type of the relay we use. Okay, just I'm going to operate it manually by using a switch. So this battery will supply a 9 volts to the relay, and the relay has the connection. Second, I'll zoom it a bit, I guess. Zooming is not possible, that's fine. You can observe in the diagram, this is the one end of the positive terminal of the power supply, that is the 9 volt battery, and this will be connected to this when the 9 volts is applied to this. You can observe this side, there will be one more terminal will be there, which is normally connected. This is normally connected and this is normally open. So I have used the path. This is common terminal. There will be two common terminals will be there in a relay. So I'll show you in a simulation time. This terminal will be connected to normally connected before, and this is normally open. So I have used normally open terminal. Okay, so the negative terminal of the battery is connected to the cathode of the LED. The anode is connected to a resistor, and the other end of the resistor is connected to a normally open terminal of the relay. And this is the coil 1 or the terminal 1 of the coil. This is the terminal 2 of the coil. So as we saw in the pre diagram yesterday, yeah, this is the terminal 1, this is terminal 2 of the coil, and this is common, and this is normally connected, this is normally open. So to use the load, we try to use common and normally open to connect the load. Yeah, let's see the simulation of this now. We'll see. Yeah, you can see this is the common terminal. You can use either this or this, doesn't matter. The terminal 1, terminal 2, and this is normally open. Actually, this is normally connected. I'm not going to use this. So when a voltage is supplied between this terminal and this terminal by the battery, this relay is energized, and this terminal will be connected to this. Okay, so automatically it will be connected to this. So now let us see. Let's start the simulation now. See, you can see the position of the switch. This is the slide switch. I'm going to use it here now. This is terminal 1, this is terminal 2, and this is the common terminal. Okay. So by default, when the switch is at the left side, this common terminal will be connected to this. So this circuit will be closed. So this circuit will be closed. So the 9 volt, whatever the supply I connect here, that will be supplied between these 2 points. So the circuit is closed. Hence, the relay is energized. Therefore, this terminal, which is common, if you are joining, just I'm going to allow. Okay, fine. So now the switch at the left side. So the circuit is closed. 9 volt is supplied to the relay. Therefore, this common is going to be connected to normally open. The circuit is closed. Therefore, the LED is on. So you can observe now. I'm going to use the 2 separate power supplies. One supply uh, to supply the give the supply to the relay, and another battery to give the supply to the LED. Okay. Now I'll click on this switch. It will slide to the right. The circuit is the broken because this common is not connected to the side, so it's connected to the right side, which is open circuit. Hence, there is no supply. This terminal will be connected to the normally connected. Therefore, the circuit is not closed. Therefore, there is no supply to the LED. It is off. So I'll click once again. Now 9 volts is supplied to the relay. It is on. So this common is connected to the normally open. Now it has become the closed circuit. So LED is on. So like this, we can. This is the manual connection I am going to use. Now we can make this supply to the by the Arduino. That is also the possible. So that will be the helpful for us to use it in real time applications. Yeah. Now let us see one more interfacing, which is very important. Which is the ultrasonic sensor. So as we know, the ultrasonic sensor will have a transmitter and a receiver. This is going to be used, the widely used sensor in the robotic applications and the burglar alarms and some security issue systems and all those things. So now let us have a look at the uh, sensor, and it's here I'm going to use SCSR04. It has 4 terminals are there. As usual, one is VCC and the ground, and 2 more terminals. Yeah, this is VCC. It is the ground. VCC is nothing but we can apply the 5 volts, and this is ground, which is the negative terminal of the circuit. Yeah, still many are joining in between. That's fine. And this is the trigger and echo. Okay, the trigger, in the sense, it will send a signal, and echo, it will receive the signal on that. You can see on the right side, this is the transmitter and this is the receiver. Okay, so a transmitter will send the signal, it will hit the object and comes back to the echo. Okay, this plays a very important role in so many the projects. Some of the features of this sensor, which is the ultrasonic sensor, are the VCC, which is the 5 volts, and the trigger. Trigger pin is the input pin for the Arduino, and this pin has to be kept high for few microseconds, usually the 10 microseconds, to initialize the measurement by sending the ultrasonic waves. And echo is the output pin. This pin goes high for a period of the time which will be equal to the time for the ultrasonic wave it turned back to the sensor. Means it starts from the trigger and goes to the object and hits and comes back. So for that time, this echo will be on, and depending on that, it will identify how much time is going to take. And 1 second, still few are joining this time. Yeah, this is the ground as usual. Some of the features of this ultrasonic sensor are: it operates at the 5 volts, and theoretically it can be used to measure the distance between the 2 centimeter to 450 centimeter. And practical measurement usually should be between 2 centimeter to around 80 centimeter. It works better. Sometimes it may be more than that, but the accuracy will be a bit less. So it is, the accuracy is 3 millimeter. The measuring angle covered within the 15 degree, and the operating current is 15 milliampere, and the operating the frequency is 40 kilohertz. Some of the applications, as I said, used to avoid and detect the obstacles, or the obstacle avoiding robots and all. We try to use such sensors, and used to measure the distance within the wide range of from same 2 centimeter to around 400 centimeter. Can be used to map the objects surrounding the sensor by rotating it. Depth of the certain places like well, pits and all, so we can use the sensor. So as I said, this has the transmitter and the receiver. So this is the distance. So you can see the equation. The distance is going to be measured using the equation as time into the speed of the sound in air. That is, ultrasonic sensor will the waves will travel with the same speed. That is a 340 meter per second, or accurately 343 meter per second, divided by 2, because the distance is actually this distance will measure the distance to travel for the wave from sensor to the object, and from object to the sensor back, that is the receiver. So once we divide it by 2, the distance is the exactly only from the sensor to the object. So divide by d. Okay. These are the some of the equations. uh, See, we know the velocity equal to of the sound is 40 meter per second. It is a 340 meter per second. If you convert it into the centimeter, just multiply it by 100. That is a 3000 of 34,000 centimeter per second, and convert it into the just multiplying and dividing by 10 power minus 6 because micro. Okay, that is if you convert and modify this equation, you will get the v is equal to 0.034 centimeter per microsecond. So because this will be send the signal in microseconds, so it's better to convert into microseconds. This is the equation, the finally the same equations I have put in this equation in the beginning itself. So the distance equal to the time into 0.034 divided by 2. As I said, why it is divided by 2 is only one way distance we have to consider. So usually we use this equation or some other modified equation of the same depending on the programming. Now this is the same what we discussed so far. This is one of the project. Okay, it's a doorbell using the ultrasonic sensor. You can utilize this technique for any such kind of applications. Doorbell using ultrasonic sensor in the sense whenever a person stands in front of that ultrasonic sensor, or if you put the some hand or on that, so automatically the buzzer will make a sound, or we can connect this to this. Here just I'm going to use the buzzer and an LED. The LED will glow as well as the buzzer that makes the sound. Okay, we can connect a relay for this uh, before the buzzer, so that instead of the this small buzzer, we can connect the doorbell what we have at home. That is also the possible one. Then it becomes what the real time the project. Okay, so to interface any project which we do in the lab to the relay, then relay can direct the high voltage and high current to the real time devices at our home, or for all the home appliances. That becomes the real time project. Okay, now we'll go for the simulation of this. So as you know, once we are using it online, it will take a small amount of time. Yeah, you can see this is the ultrasonic sensor. I think the connections you can observe now. This is a VCC. Okay, it is connected to the 5 volts of the Arduino. Okay, and this is the ground. This is the ground terminal. It is connected to the ground of the Arduino, and this is trigger, and this is echo. I'm going to use two terminals of the Arduino. There is 11 and 12. Okay, and just as usual, this is the ground. For this ground, the LED is connected. The cathode of the LED is connected, and anode is connected to one pin of the Arduino, which is pin number 3. Okay, through a register, and pin number 2 is connected to a buzzer, and the other end of the buzzer is as usual to the ground. Okay. Now, let us see what it does. So, whenever an object is near to this sensor, the LED will glow. At the same time, the buzzer will come. Okay. Then I'll show you the program and explain it. Yeah, to simulate this, just you click on this the buzzer, an object will you can see the object. We can move this object either away. Just you click the mouse and or the tab in the laptop. Just you drag it either away or towards the sensor. So we will see the actual distance between the object and the sensor. It will be displayed in the inch as well as in the centimeter. That is now it is 56.4 inch or 143.1 centimeter. Okay. Now it is too high. Slowly, I'll decrease the distance. Just you observe. Hope you are hearing the sound. Like the sound is coming, I guess. Okay. So that depends on the how much distance I put in the program. You can observe now. It is now it is a 30.6 centimeter. No sound. I'll decrease the distance now. Is a 25.6 centimeter now. See, now it is a 24.6. Means I have given the distance as what 25 centimeter. If the distance is less than 25 centimeter, it gives the sound. Otherwise, not. So whenever a person or any object comes within that range, so that it gives the buzzer sound at the same time, the LED will glow. Okay. Now let us see the program. Also, I'll show you the simulation of. Once again, you look at the simulation, and here I open the code. This is the code. I'll explain the code a bit later. Now, just below this, there is a serial monitor. If I click on this, you will see it. So what exact the distance it is there now? You can see 38 centimeter is going to display. Now I'll move up and down. Of course, the decimal digit is not being displayed. We can do that also, not a problem. I'll increase the distance now. So it will change. Now it is a 79 centimeter. Now it is a 135 centimeter. Okay. Now it is so we can move up and down. And I'll decrease the distance. You can see now. So now it is 29, 25.5, so 24 points. So now it is so like this. So we can see. Now let us see the program. Yeah. In the Arduino, as we are going to see, the sensor has 4 terminals are there. One is VCC, ground, and the trigger and echo. So we are using, apart from those two, we are using one LED and one buzzer. So as usual, the 5 volts is connected to the 5 volts. The VC is connected to 5 volts. The ground is connected there. Apart from those, we are going to use the 4 terminals, the pin numbers 2, 3, 11 and 12. Okay. For pin number 2, I'm going to connect a buzzer. So just we can give the name as the buzzer also, not a problem. Just I'm going to maximize this.
Sir, what happen if we increase the height?
Ma'am? Hello? Hello, ma'am?
Sir, what happen if we increase the height?
Still
If we
further?
increase,
Still further you telling?
yeah, sir.
One second. See, this distance I can increase it. So it has the limit of this is the maximum. Beyond this, I cannot go ahead. So the maximum distance is what 188.8 centimeter in this particular simulation. So we can't go beyond that, I guess.
Okay, sir. Thank you.
Yeah, but of course in the real time application we can put the object within the range of what 2 centimeter to around 400 centimeter, but it is not advisable. It may give some the errors also if the distance is more. So within the range, now you can see I cannot go further. So within this range I have to operate it. That's it. Okay. Yeah. Now close this. 12, 11, these are the pins. I think you understand this. Just we can declare this inside the setup also, but we can give the names for them according to our convenience. So just I'm giving the names, the int, these are the variables, the trigger